Lazy loading, also known as infinite scrolling, is a design pattern that involves waiting to load data on an app until it's needed. You probably come across this technique on a regular basis, either while scrolling through YouTube videos, emails, or your social media feed. Lazy loading is very useful since it helps improve the speed and performance of an application. The way it works is when you first load an app, a call is made to the backend to load an initial chunk of your data rather than all the data loaded in at once. Because if you did this, depending on how much data you had, it could take a really long time to load and would lead to an unpleasant experience for your application. So instead, as you scroll down the page, more calls are made to the backend to fetch more data, and chunks are added a bit at a time until all your data has been added. In this video, I'll be showing the full stack implementation of lazy loading. I'll be using Express.js for the backend, Postgres running in Docker for my database, and Vue for my frontend, as well as a few other dependencies and tools just to help me run and build the project. The first thing you need to do is install Docker. If you don't already know, Docker is a tool that allows you to run software in a virtualized packages called containers. We'll be using Docker to create a Postgres database that will use to store our lazy loading data. So once you've installed it, you can pull the Postgres image using the command docker pull Postgres. So after we pull your image, we can use this command to run our container. What the command is saying is that it's running this container in port 5432. The password that we're using for our database is going to be my secret password. The username is Postgres, and our database is going to be called initialdb. So once you have your Postgres container running, you're going to want to connect to your database. I'm using this tool called Table Plus, and what you're going to want to do is use the username, password, and database name that you use to run your Postgres container to connect to it. And we click connect, you should be able to see that you're connected to your initial DB. Right now we don't have any tables or any data, but once we add some, it's going to be very useful so that we can make sure the data is being added. Now we can create a lazy load folder, and inside here we're going to add two additional folders. One lazy load FE to store our front end code, and another lazy load BE for our backend code. Once you have these folders, you're going to want to make sure you have Node installed since we'll need it to build both our front end and back end projects. Now we can start setting up our backend. We'll start by cding into our lazy load backend folder and running npm init to create a new node project. At this point in your backend folder, you should see a package.json file. We'll be using this to install some dependencies. So if you're not already, you'll want to cd into your lazy load backend. To install the dependencies, we need to run npm I followed by these next dependencies. The first one is going to be Express. This will be used to build our API. Then we're going to also install .env, which will help us use environment variables. Next is cores, and we'll use this stat configuration so our front end can use our backend service. Next, we'll use Axios. This will be used to fetch data from another API to populate our database. And then we'll use at database slash pg, which this dependency will allow us to connect and interact with our Postgres database from the backend. We'll also be installing NodeMon as a dev dependency so we don't have to start and stop our API every time we make a change. After you've installed all your dependencies, you'll want to create a .env file to store our environment variables. Inside this file, you'll want to add a Postgres underscore password with the password you use to start up your database. Mine was my secret password. You'll also want to add a Postgres underscore user with the username for your database. Mine was Postgres. And finally, a Postgres underscore DB for the name of your database. Mine was initial DB. This is best practice since we don't want to hard code any username or passwords. Next, we'll create a new JavaScript file called dbconfig. This file will set up our configuration and connection to our database. We'll start by creating a constant called create connection pool, which will require our database slash pg dependency. Then we'll create a constant called .env, which will require our .env dependency. Next, we'll say .env.config, and we'll create a constant db, which uses the create connection pool and passes in a URL. This URL will contain our environment variables with our username, password, and database name so that we can connect to our database. Finally, we'll just want to export our DB so that we can use it in other files. Next, we'll create another JavaScript file called DB. In this file, we'll add some code to create a table and populate it with some data. First, we'll add some constants to the file. We'll start by adding a SQL constant that requires our database dependency, and it'll be used to help us write queries to our database. Then we'll bring in a DB constant, which requires the file we just created, dbconfig, and it'll be used to set up that connection. And then we'll have an Axios constant that requires our Axios dependency, and we'll use to fetch some data. The first function we'll make is a async function called createTable, which will use our DB object to write a query to create a table if it already doesn't exist, called lazy data. The properties this table will have is an ID, which will be self-incrementing, and it'll be our primary key. It'll have a title, a URL, and a thumbnail URL. The next function will be called addData, and it'll have three parameters: a title, URL, and thumbnail URL. And it'll be used to insert new rows into our lazy data table by, by writing a query that inserts into the table and passes the values of those parameters. Next, we'll create a function called populateTable, which will use Axios to make an API call and return some mock data. The data I'm fetching comes from this page called JSON placeholder. I'll be using their photos endpoint to retrieve some photo data. In total, it returns about 5,000 photo objects, but I'll be filtering it out so that it only returns about 100. We'll be looping through this data and using the addData function to add a new row for each object into our table. Once the data is returned, we'll loop through each object and create a new row inside of our table using the addData function. From here, we'll create our last function called run, which will hold our create table and populate table function, and then finally just dispose of our database connection. Then we can use this function with a catch block. In case any errors come up, we'll log the errors and exit. Once you've done all this, we'll go back to our package.json file and add a new script called data, which will run the command node db.js, which should just run this file we just created, and in the process, create a table and populate it inside our database. Next, we'll be creating the API that we'll be hitting to retrieve the data. We'll create a new JavaScript file called API, and we'll start by adding our constants. We'll need an express constant. Again, we'll use DB and SQL constants, and we'll have a course constant. Then we'll create an app using Express. We'll have a course options constant, which has origin and a wildcard. This is going to be used to help us connect from our front end to our back end. We'll type app.useCores and pass in those cores options. Now our default endpoint will send, this is the home page, and then we'll have another endpoint which the path will be data to retrieve our data from the database. This will look for a parameter called offset, which will have the position of where we'll start retrieving the data from the database. We'll be creating a function called getData, which passes in this offset and then returns the items. This will be an async function that has a parameter offset. If offset doesn't exist, then we'll by default set it to 0, and we'll create a response which will wait for a new promise. Inside of here, we'll set a constant data, which will get the data from the query using the DB and SQL constants. We'll write a query to select from our lazy data table, ordered by ID in ascending order, and the limit will be 10 of how many objects it returns, and the offset will be passed in by the parameter. If data is returned, we'll resolve. If there's an error during this, we'll catch the error and reject the promise. Then we'll just dispose of the DB connection and we'll return the response. Now we'll just add a constant port and set it to 3000. This is where our API will be running. Now we'll just type app.listen and pass in that constant port. And then whenever it's running, we'll console.log server running on port 3000. Now to run this, I'm going to create a script called API, and the command to run is going to be nodemon API. But of course, you could just type in this command in your terminal, and it should work the same. Then we can just npm run API, and we should see our API running on port 3000. And if we go to our data route or data endpoint, you should see 10 objects coming back. So it's working correctly. Now, the nice thing about using nodemon is if you make a change, so if we go back into our default endpoint and we change this message to hello world and then we save it, it'll automatically refresh and we should see the changes and we won't need to stop and restart our server anymore. Now we'll move on to our front end. Like I mentioned, I'll be using Vue and Vue CLI to create a new project. So if you don't have Vue CLI installed, you can install it using this command. One thing I forgot to mention is when we run the command to build a new project, it will automatically create a folder for our front end, so you can delete the other one we created earlier. So to create the actual project, we'll run vue create lazy load fe. This will create a new Vue project for us. Once it's done building, we can cd into the project, and to test out, make sure everything is working, we can run it with npm run serve. If everything's working correctly, it'll by default run in port 8080, localhost 8080, and we can see here that everything's working. Now I'm going to install some dependencies that we use in the project. Again, we'll be using Axios, and this other dependency, Vue Spinner, is just going to be used to bring in some loading components so we don't have to build our own. Start by importing Axios. We'll remove this hello world component since we won't be needing it, and we'll create a data function that returns these objects. We'll have an items object that'll store all of our uh, items that we retrieve from the API call. And now we'll add a mounted function. So that once this page is mounted, we will make a call to our local backend, hit our data endpoint, and pass an offset of 0. We'll get the first chunk of data, and then once we get the response, we'll set our items to the response.data, and we'll add a catch block for any errors that might come up. We'll just print them. So for our HTML, we'll remove this. We won't need it. We'll add a div, and inside of this div, we can add a h1 tag, which will be like just our title for the page. It'll say lazy load, and then we'll add another div. Inside this div, we'll add an item class and a container class. Next, we're gonna loop through our items object and use each item here in our HTML. So we need to have a key. We'll set our key to the index, and now inside of our div, we'll add an image tag with a class image, and we'll set our source to each item's thumbnail URL. Then we'll add an h2 tag, and Inside of here, we'll set the item.title. Now we want to make sure that our backend is running before we test this out, so we can cd into our lazy load BE and run the npm run API. Then come back to the front end and we'll run npm serve again. Once it's running, we should see if we hit localhost 8080, we should see some data coming back. We should see our title and some data coming back from the API. Doesn't look very pretty yet, but we'll fix that by adding some CSS. We'll start off by adding our body, and we'll set the background of our body to this blue color. Next, for our h2 tags, we'll give it a margin of 0, padding of 50 pixels, set the color to white, and the font size to 32 pixels. Then for our h1 tags, we'll set the color to white and the font size to 62 pixels. Now for our paragraph tags, we'll set margin 0, padding bottom to 30 pixels, and colored white. Now we'll add our container class. We'll set this background color to this gray. Our margin to 20 pixels. Our height to 50%. And our min height 200 pixels. So we'll add a border radius of 25 pixels. Then we'll add our item class. It will display in flex. Now we'll add our image class. We'll set the padding to 25 pixels. Our border radius to 50% and position relative. Our top will set to 0 and left will set it to 0 as well. So now we go back to our web browser and we refresh. We should see something that looks like this. Looks a little nicer now. And if we check the network call, we can see the first API call coming in. And if we check our endpoint in localhost 3000, pass offset equal to 0, we should see this is the same data that's getting passed. Now that we have that going, we'll start getting our lazy loading to work. First thing we're going to do is import this pulse loader, which is going to be just our loading animation. We'll get it from view spinner source pulse loader.view. We'll add it to our components. Next, we'll also add this loading boolean. We'll set it to false. Then inside of our mounted function, we'll add an event listener for scroll, and it'll use this handle scroll function, which we'll write in a second. Then we'll add an unmounted function, which will remove the event listener. Again, it's going to be scroll, and it'll be that same function passed in as the parameters. Now we'll add our methods, and here we'll add that handle scroll function or method. We'll set some constants. We'll have a scroll top, a scroll height, a client height, and these will all come from document element. Now we'll add an if condition. If the scroll top plus the client height greater than or equal to our scroll height minus 5, and our items dot length is less than 100, and this dot loading is false, then we'll make loading equal to true. We'll make a get request to our localhost 3000, hit the data endpoint, and this time pass an offset of the length of our items. Again, once we get this data, we get the response, we'll we can well, first thing I'm gonna do is set a timeout. This timeout it'll actually let us see the loader because without this it would run pretty fast. But inside of this timeout, we'll push the new response data to our items, and we'll set loading to false. This timeout will be 2 seconds, and then we'll add a catch block for any errors that might come. Now in our HTML, we'll add a new div, and inside of this div, we'll add an if condition. So if loading is true, then this HTML will be displayed, and then our class that we'll add is loader. And then inside of the div, we'll add a paragraph tag that says loading, and then we'll add our post loader component. There's some properties for post loader. For loading, we'll set this equal to our loading boolean, and we'll add another object called loader color, which will be set to white. And this is how we'll set the color of our post loader, because by default it's a green color. And just to keep it all consistent, I'll make it white. Now we'll add our class, loader class, and it'll just set the paragraph color to white and our font size to 32 pixels. So if we save this, go back, you can see the loading animation. You couldn't see this if we didn't add the 2 seconds of timeout because it'd probably be happening really fast, but you can see more and more data is being loaded. And if we check our network tab, we'll refresh, we should see the first call to the API, then we'll see another one passing an offset of 10, then an offset of 20, and now 30. It'll continue uh, to get the data starting from a different offset each time. It'll keep going. It should keep going until we reach 100 items. So the last offset we'll pass will be 90. So here's the last one. Now you see, won't nothing else will happen once we get all the data. This is the last item is as an ID of 100. So we've retrieved all of our data from the database. And that is the end of the video. Hopefully you were able to follow along and learned a lot from this video. I'll have all the links in the description below. I'll have my GitHub repo so you can just check out the project if you'd like. But again, thanks for watching and until next time.